Well, hello Internet, and welcome to part 5 of my object-oriented design tutorial. Today we're going to take everything we made in the past parts of the tutorial and create a sequence diagram from it. And if you don't know anything about sequence diagrams and you want to know everything there is to know about them, there's a link in the upper right-hand corner. You can click on that. But for the most part, everything should be pretty self-explanatory. So let's get into it. Okay, so in the previous parts of the tutorial, we created a whole bunch of different things. We went and created our domain model, and what that's going to provide for us is now we know what all the objects we're going to use. We're going to use ATM, we're going to use customer, we're going to use account, bank computer, bank network, card, and transaction, which you'll see down here. There's transaction. That's what we made in the last part of the tutorial. Also, we know how things are going to be communicating in regards to ATM, to the bank network, and all this other stuff. And on top of that, we created a very detailed usage diagram, which you can see here. And I'm going to have this laying in front of me, and just off of this, I'm going to create the whole entire sequence diagram. So if you'd like to get the usage case and put that in front of you to help you along in this tutorial, that would probably be a really good idea. Otherwise, like I said before, you can just follow along. So now let's start creating a sequence diagram. Okay, so now a sequence diagram is just basically going to show the interactions between all of your objects, which you can see here in the left-hand corner, and the different events that are going to go back and forth between these and how they're going to react and interact with each other. This is the step that comes before creating the class diagrams, and then with the sequence diagrams and the class diagrams, if we put those together right, we're going to easily be able to write our program. So all we need to do now is we already have these guys. I have everything set up here on our screen. I'm going to zoom in a little bit further. So here we go. We got everything here that we basically are going to need. So I'm going to put customer down first, and then I'm going to go through and just start creating everything and showing how all these different objects are going to talk to each other. So the first thing we're going to do, put customer inside of there. We also know that we're going to need ATM. Let's take him over and throw him in here just in some arbitrary space. And then we're going to put these little nodes in here, and this is going to show different points in which we plan on triggering different events. And I'm going to make this more like a real world sequence diagram. It's going to have a whole bunch of notes on it, and it's just going to be nitty and gritty. Grab this guy, throw him over here as well. I want to keep these all lined up. And then, like I said, I have the usage case here in front of me. So the very first thing that is going to happen is a card is going to be entered. And you want to make everything work for the usage case, but you also don't want to think too much about this, because remember, we're just playing around here and we want to get as close as possible. So I'm thinking, first off, what I'm going to do is I'm going to actually call or trigger an event on the customer object, and I'm going to set this up just like a regular old method. You can see method attribute, the class of the attribute, and the return type. And I'm going to call this guy by a certain name. Let me see here. Just think this out. So I'm going to call it exactly what it's doing. Insert ATM card, and what is going to be inserted inside of the ATM card? Well, I'm going to put the card, and then after that, the class type of the card is going to be card, as we saw previously. And the return type on this, I'm not certain about, but I'm thinking it's probably going to be a Boolean of some sort or another. It's either going to come back true or false. So I just have to make myself some room inside of here for all this stuff, and then take this method I'm calling and drop it inside of there. Then, after that, now I realize I need to move this guy over a lot. I need to figure out exactly what is going to happen whenever I insert my ATM card, and I decided I'm going to call another method based off of my usage case and what I know I need to do from all the other things we've done previously. And this is going to be another method. And what am I going to do? Well, I need to find out if the card is readable. So each of the ATM's cards has a little strip on it. So I'm going to just say is strip readable. And inside of that, I'm going to pass the card, and then I'm just going to leave that as a Boolean for a return value. Well, there's two different things that could happen. One of them could be that the strip is going to be readable, and another thing is that it's going to be unreadable. So what does that mean? That means that I'm probably going to need an alt condition set inside of here to handle the either or situation of whether the card's going to be readable or it won't be readable. And whenever we do that, of course, we're going to put everything inside of alt, inside of this little folder type thing in here. And then there's going to be different conditions that we're going to need. So just just grab one of these condition things over here. And this is all stuff that I build inside of Omelette. And then I basically have to set my condition. So I'm going to say the card strip number is less than or equal to 0. Let's say that is a condition. And I'm going to have each of these guys perform different conditions because I don't want my ATM card to have all the information about every single account on it. That would be insecure. So I'm basically going to say, is the strip number, which I know is impossible, less than a 0 value? If it is, I'm going to mark this as a failed situation. Jump back over here, and this is going to send a message to the customer that the strip was unreadable, which would make a lot of sense. And then if this is a failed condition, I do this, everybody does this stuff in different ways. I'm just going to mark this as failed and then work out exactly how I'm going to lay that information out to the customer later on. Now, however, the ATM is also going to check for a non-failed card read. So I need to take another condition down here, drop it inside of there. And this time I'm going to say if it is greater than 0. As far as the ATM is concerned, this is now a valid card. We're also going to check it again, of course. And we're just going to take another little node down inside of here. Now, if the card strip number is greater than 0, then we're going to have to start doing things like checking against the bank network as well as the bank computer. So we're going to have to come over to this guy, grab him, and I'm also going to grab this one, copy those two guys, and we're just going to bounce them inside of here like so. So now I'm going to have to send a message. And another thing to think about is what happened to the other objects. Remember, I said transaction and card should also be included inside here. However, I did not use them. In those situations in which I know I am going to have to use these things, I'm going to have to think about who's going to have them. Well, it definitely makes a lot of sense for the transaction object to be inside of the ATM. It also makes sense to come in here and put a little note. So I'm going to say holds transaction. That is where we're going to create our transaction object at some point, and I'm just going to draw a little line over here to show that. And some other things that might come up is this is probably not a great answer, but remember, we're just trying to get to code as quickly as possible and have this guy work. However, more than likely, this is going to be something completely different. We're going to be verifying strip numbers on the ATMs, not based off of whether the strip number is 0 or what have you. But for now, this holds, and we want to just get some code going here. So what I'm going to do here is say change to what is a valid magnetic strip code in the future. Drop a little note inside of there, and then take this guy here, and then whenever we start to get to the code level or creating class diagrams, we're going to know that that's something else that we're going to have to think about. Okay, so now we know we have a valid strip, and this guy over here ended, so we don't have to worry about that one. So we're going to have to figure out, okay, well, we have a valid card now, so what exactly are we going to do with this card? Drag this down here a little bit, give me a little bit more extra space. We're going to call another method on bank network. Drag that over there, get one of these little nodes, drop it right inside of here. Now we're going to create ourselves another method that is going to be tied to bank network. See, this guy over here is strip readable. That's going to be tied to the ATM object. And this one, which we're going to call find bank associated with card. Find bank associated with card, and we're just going to pass it the card as well, and I'm also going to leave that as a boolean, and then I'm just going to take this guy here and drop him inside of there. So eventually we're going to be calling find bank associated with card on the object that is named bank network. That's all that means, and that's going to be some point in the future. So I'm basically working out what my different methods are going to be. So this is very, very important. Usage case is probably first in regards to importance in designing all this stuff. And the second most important thing is sequence diagrams, at least as far as I'm concerned. So there we go. Now what's going to happen? Well, the card's either going to be associated with one of the banks in our bank network that's tied to this ATM machine, or it's not going to be assigned to one of those. So what does that tell you? That means I'm going to need another alt. So let's come in here, straighten this out a little bit, and then I'm going to create another alt, and then we're going to throw another condition inside of the alt. This time the condition's going to be, I'm just going to say the card, just like we have here, except in this situation, I'm going to say bank ID not valid. You always want to put the thing that's going to return a false or a fail first in these alt conditions, almost always, because that just clears everything up and makes everything a little bit neater and easier to deal with. And in the situations in which that's going to occur, we're going to be returning a fail back to the ATM, like that. And then I'm just going to grab fail here and throw failed inside of there. worry about what that means or what that's going to do in the future. Now, what's the other condition? Well, the card is valid. So in the situation in which it is valid, I'm of course going to want to do something completely different. I'm now going to want to get bank computer involved, which is going to be an individual bank computer. So just create another node for it, create a node for this, and then I'm also going to take this method here and just reuse it because I'm basically just doing exactly the same thing again. And in this situation, this is not going to return fail. Instead, it's going to return success because now we know that we actually have a valid card that has been entered. So we're just going to change this to success. So there's a lot of logic that's basically being done here, and this is going to save us an immense amount of time whenever we have to start writing our class diagrams. Okay, so now we know we have a valid card. And let's just have all of these go the whole way across. So I'm going to go copy on that and then just drop some nodes down inside of here as well. And then basically do the same thing here with our customer. And there we are. So now we have success coming the whole way back. Everyone involved, including the customer, is going to be alerted that yes, we can read the card. So now what are we going to do? We're going to have them insert a pin, just like the usage case says. So now we're going to get ourselves another node here, draw in another lifeline, move this up a little bit so that we can see here a little bit better. And then we're going to draw another one in, of course, for all the other nodes that are going to be participating. So the next thing I want to do is have the customer insert pin. And insert pin is actually going to be on the ATM object that we're going to be creating here. So let's drop this guy inside of here. And I'm going to say insert pin, and it's going to be passed a card again. And as well, it's also going to be passed a pin, which is going to be an integer. So I'm going to put that inside of there. And for now, I'm just going to leave Boolean inside of there as well. Now, if they insert a pin, one of the things I'm going to have to do is make sure it's at least 4 digits in length. So go and throw an alt in there, just like I'm sure you were expected. And then we have to do a condition again. And in this situation, I'm just going to go pin length in this situation. And then not equals in UML is actually like this, but you could also just do it like the more common way, whatever you want to do with it. I'm going to stick with the defined way of doing it. So I'm going to say pin length is not equal to 4. And that tells you a couple other different things. Can't really get into exactly how we're going to calculate this, but let's say that I think to myself, well, there's a way that I can programmatically figure out how long the integer is, and I want to define that for the programmer later on to save them some time. I could just slop in another note, and then I could say I could find pin length with an algorithm, which is going to be, say we want to cast this to an integer, and then I can go math log 10 pin plus 1. I know that that's going to give me the length of my integer that I entered, and it came to mind, so why not throw in a little note inside of there to save the person some time. Now in the situation where it's not equal to 4, what does that mean? That means it's a failed scenario, so I want to send a message back that says that this failed, so just type in failed. Now in the situation where it did not fail, handle that as well. Another little node inside of here, drop this down here. Like I said, this is all coming off the usage case. Now you could either put else inside of here, or you could type in pin length. And again, with UML, equals is this way for conditionals, or you can do it that way. Either way, people are going to understand what you're doing. I'm just going to leave it the basic UML way to define these things. And under the condition in which the pin length is equal to 4, which means it could potentially be a valid pin number, then I need to call myself some more methods. Grab that, grab myself an arrow, and then ultimately what I'm going to be doing is I'm going to be passing information. It's going to go through the bank network, but it's going to ultimately go to the bank computer objects that I'm going to create. So in that situation, I'm just going to have bank computer, and I'm going to act like everything's going directly to it, just so things aren't quite so confused. And I could put up another note and say, hey, I'm just talking to bank computer network here, but ultimately what I'm doing is talking to the bank network that's then talking to the bank computer, but blah, 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 blah. Don't let that confuse you. I'm just doing this for neatness situations so that the sequence diagram is a little bit easier to read. So now what I need to do is actually verify my pin. So I'm going to say verify the pin, and it's going to be passed a card, and it's also going to be passed a pin number, and then somehow in there I'm going to figure out exactly what that is. Now what happens? Hey, I have to verify a pin. So that means what? There's a situation in which it might not be valid, so I need to throw another alt inside of here. So you're doing the same sort of things over and over and over again. So that means I got to get a condition inside of here. Drag that guy over. And in this situation, I'm going to say pin is not equal to, and I'm going to say the account. I'm going to store an account object inside of bank computer, so I should probably say that. So I'm going to say Copy that little note there, and in this situation I'm going to say holds my account objects, because really they shouldn't be anywhere else except inside of the individual bank computers. You don't want accounts being shared between rival banks. So there we are. So now I know that my account object is going to be inside a bank computer. And I'm just going to stretch this out a little bit. And I'm going to say the account dot pin, and there we are. So if it's not equal, what does that mean? That means it's a failed scenario. So I have to say, hey, this pin is not matching the one that we have on record. So that's a failed scenario. And then in this situation, this guy should be down here like this. And you could just stretch this guy, and then we're going to say failed. And maybe we want to send specific information back in regards to how it failed or whatever, but for right now we don't know that, so we're not going to worry about it. We want to divide this guy up to handle situations where they enter the right pin, and that's going to do that for us. And then we're just going to get ourselves another node, and in this situation we're going to say that the pin was entered correctly. So I'm just going to say equals, drop that down there, and there we are. Now in this situation we know that our pin was entered and it was entered correctly. So instead of failed, this is going to return success. We got to drag this down here a little bit more. Actually, you don't even have to. It's all up to you. I'm going to actually drag that down there. So now we know that both the card entered is correct, and we also know that the PIN number entered for that card is also correct. So now looking at the usage case, and let's go and tell the customer as well that this is correct. And we'll do that just by marking this as success. And if you haven't seen previously, it's so easy to write code after you do a sequence diagram the right way. So now what do we need to do? Well, we need to request account to access. And you know what? I'm thinking to myself, that would probably be a good thing for the ATM to do after it reaches a success scenario. So we're going to leave success marked on here. And I'm in essence going to kind of put a note inside of here that's going to say, hey, your job is to figure out as the programmer how exactly you're going to request that the user enter the account that they want to access. So I'm just going to do that as my return. And I'm kind of playing the role of both a whole bunch of people standing at a whiteboard and conversing and thinking about how to solve problems, as well as a person just doing a regular sequence diagram, so you can see both angles. So there we are. So now it requested the customer to enter the account that they want to use. So what we're going to do now? Well, we're going to come in here and we're going to expect the ATM to receive a request for the account to be used, which is going to be either savings or checking. And that also means we're going to have to come in here and figure out a name. And based off the usage case information I have here in front of me, I'm going to call this pick account to access, abbreviate that a little bit, and I'm going to say the card, which is of type card, and I'm going to say account, and I'm going to pass this as a string. I could also go and put in a note inside of here. We're going to have to verify the string can either be of checking or savings. I'm not going to do that, right? What the heck, I'll do it. So I'm going to come down here, paste it in here, account string either starts with AC or S. How about that? So there's a little note that the programmer can use whenever they're going through here. Just something that I'm thinking of, and that's what the notes are there for. Now, it doesn't make much sense for the ATM to send a message over to the bank computer saying, well, this is the account we want to access, and then ask for an amount. It makes much more sense to find out what account do you want to access, and then after you figure that out, what amount do you want to access, or what amount do you want to withdraw? So in those situations, we want to actually just say, okay, how much do you want to withdraw from checking or savings, whichever one you chose. And then on top of that, we're going to throw a little note inside of here, and this is where we're going to create the transaction object, or we're going to add information to the transaction object. So inside of this guy, this little note, we're going to say add account to transaction. So now we know that we're going to add the account that we're withdrawing from to the transaction. Makes a lot of sense. And then we're also going to take this little guy here and say, okay, well, the ATM object is going to ask you a question. And that question is going to be a request for the amount to withdraw. So now we know that. And then it's going to be the customer object's job to say, okay, well, this is how much I want to withdraw. And then we can worry about later on if it's the right account and the right amount and all these other different things. I'm going to try to get these sequence diagrams from getting too complicated, because they're very easy to get complicated if you don't watch it. So I like to use notes. Some other people have other different things they like to do. All right, so we got this in here. And the new method we're going to call on the ATM is going to be amount to withdraw. And all of these names, of course, should make sense to somebody that reads them. And what are we going to pass this time? Well, we're going to pass the card, again, just like we did before. But we're also going to pass some more additional information. We're going to pass over the amount that we want to withdraw, and that's going to be an integer. You might think it makes sense for it to be a double, but this is an ATM machine, it doesn't handle coins. And then what we can do is also say add not only the account to the transaction object, but also enter the amount. And that allows us to put everything all in one place so we can send this transaction over to the bank computer for processing. That's going to save us a ton of time as well. So we're going to come in here, grab this guy, throw him down here. And this is going to be a message that ultimately is going to go through the bank network, but get to the individual bank computer. And then we have to send a message to this guy. And based off of the usage case, that message should be something like request withdraw amount. And I'll just abbreviate that. And then in this part, instead of amount, and in sending the account and all that other information individually, I'm going to send it as a transaction, which is going to be a transaction object. Now I'll be able to deal with it like it's an object rather than it's, some random programming thing, which would be bad. So what's going to happen now? Well, I'm asking it a question. I'm saying, can I withdraw a certain amount of money out of either my checking or my savings account? Well, in that situation, we're going to need to perform some checks to see if that's okay or not. And the check that we're going to be performing here, transaction, and I'm going to say the amount, which is going to be a field inside of that guy, inside of the transaction object. I'm kind of simplifying this a little bit and just relying on the programmer having some common sense. I'm going to say transaction, the amount, and then I'm going to say the account, which is the account object that is stored. I'm going to see if the amount in the account is greater than, and I'm going to check if the amount in the transaction right there that they're asking for is greater than the amount of money that they have in the account. And if so, guess what? That's a failed scenario. So I need to send back a fail message. However, and like I said before, we could also throw else inside of here. So this time, just to save some time, we're just going to say else. And in this situation, we're going to say something like, what is the new balance? Because we already have the transaction information. We want to pass back name and all these other things that we've already grabbed. So what's something that we could pass back? Well, we could send back the new balance for the account after the withdrawal. Makes some sense. So inside of this little return thing here, I'm just going to type in return new balance and then let the programmer figure out exactly how that's going to be done whenever they decide to return that. And then this guy as well, being the ATM, is going to return a receipt to the customer. However, we're not quite sure exactly how we're going to do that. So I don't want to leave it out, but I also don't want to make guesses on anything that I'm not 100% certain about. So instead, in this situation, what I'm going to do is tell it what type of information should be sent back to the customer after a successful transaction occurs so that a receipt can be printed out. And inside of this little box, I'm just going to say, give money, receipt, and card. So there is a basic sequence diagram. Everything that I've created here is actually available underneath of the video, and it's actually a little bit neater than this. And in the next part of the tutorial, I'm going to show you how easy it is to take all the stuff right here and convert it into a class diagram. Please leave any questions or comments below. Otherwise, till next time.